Hello, chemistry people. Amy here. What I've got for you today is one of the very first prescribed practicals determining the molar mass of butane. So when I recorded this video, I was actually in my year 11 class, so I had to mute for privacy reasons, so you weren't hearing my students. So I am going to do a voiceover. So we'll see how that goes. And then at the end of the video, I'll come back and I'll explain how I want you to manipulate the data. Thank you. So I start by weighing my lighter on an analytical balance. And then I have a plastic tub, which has a couple of centimetres of water in the bottom. That's just tap water. And I'm measuring the temperature of that water using a thermometer. I then make sure that I have filled up a measuring cylinder all the way to the very top, which is why this is taking me a minute. And then I put my palm flat over the top of the cylinder, and I invert it and make sure my hand is below the surface of the water when I remove it. That's to try and make sure that that cylinder is completely full with water. I then take my lighter and I put it underneath the mouth of the cylinder underwater, and I hold down the lever to release the gas on that lighter. So it bubbles up and it goes into my measuring cylinder, and you can see it's starting to fill. Now I sped this up because it started to get boring. So I sped. Now I changed the angle so you could see a bit more clearly what I was doing. So this is one-handed using my phone, which I feel I deserve a round of applause for. So that is bubbling away, forming bubbles into my measuring cylinder. You can see there I'm at about the 60 to 70 cm3 mark. I want to get it to between 90 and 100. For reasons that will become clearer when we discuss measurement uncertainties and in a bit more detail. So while we wait for this, I want you to start thinking about where some of the sources of error might be with this experiment. So I am bubbling away the the gas that is in the lighter. And what I do once I've filled up between 90 and 100 centimetres, I'm going to stop, shake the lighter a little bit to make sure there's no bubble trapped in the mouth of it. And then quite clumsily, I am going to hold up my measuring cylinder while blocking it using the measurement on the side. I am going to measure, that is actually 89 or 88. I then shake out my lighter thoroughly and dry it with paper towel in order to make sure that that lighter is completely dry. And then I weigh it again. So I take a final measurement of the weight of my lighter. So thank you for that. Let's go through how I want you to use the data. So the units for molar mass, and this is going to be helpful for us, the units for molar mass are grams per mole. And can you actually see that? Is that dark enough? Yes? Yeah. So grams per mole is the unit. Now, where do you get these two numbers from? The grams, that grams is the difference in mass of your lighter. So the difference in mass of your lighter is this grams. The moles you get from applying PV equals nRT. So N is equal to PV on RT. So this is why we put a thermometer in the water. This is why we were using a measuring cylinder. And this is why I went on Google and asked for the Bureau of Meteorology here in Melbourne to tell me the pressure. the air pressure on that day. Now, if you are one of the students in my class who missed this experiment, I have provided you a data set from one of the other groups that experimented. I want you to work through this process where you work out your mass based on your difference in mass of the lighter, and then your moles based on your experimental readings. I would like you to do that for each of the 3 data sets. So you are doing this process 3 times. Thank you. So if you are not in my class, please do not use the masses of the lighter that were in my video. I forgot to actually weigh my lighter before I did that demonstration. So I've just I did the experiment, weighed my lighter and went, gee, I forgot to weigh it beforehand. So I just held the lever down for a little while, so I did have a difference in mass. So making sure you're using an actual data set. Now, some of the problems with this experiment that might not have been obvious from just watching it on the video, that process of putting your hand over the top of the cylinder and inverting it, you've got to make sure that your hand is properly under the water before you take your hand out, or else you end up with air bubbles trapped up the top, and that would mess with your volume. If your thermometer is not accurate, it can mess with your temperature. Because the mass difference that we are looking at is quite small, if you're using an inaccurate scale, so luckily our scale was pretty good, but if you're using an inaccurate scale, the inaccuracy of the scale can be an issue. And the other thing that can mess with your mass is if your lighter hasn't been dried properly. So there were a couple of groups as we were doing the experiment that actually had their lighter increase in mass between when they started and when they finished. And that's because they didn't dry it properly. So those are our main sources of error. In order to calculate the molar mass of that gas, you're just taking the mass of your lighter, the difference in that mass, and then you divide it by the moles as you calculate by applying this formula. Again, one of the tricky mistakes that people will tend to make, because we were using a cylinder that recorded in CM3, you need to convert that into DM3 or else this formula doesn't work properly. So make sure you divide that centimetres cubed by 1,000 to put it into DM3 so we can use this formula. Okay, that brings us to the end of this video. I hope you have a fantastic rest of your day and I shall see you next time. Bye.